Welcome to New Dynasty Academy. Today we are doing trigonometry for grade 10s. I'm so excited for this lesson for today. So in this session, we'll be looking at the study of trigonometry, which is basically the study of the triangles, where we are concerned about the length of the sides of the triangles and the magnitude of the angles of triangles. Now in grade 10, you only be focusing on the 90-degree triangle. Now, without wasting any time, let's go on to this first 90-degree triangle. We know that is a 90-degree triangle because your side AB is perpendicular to side BC, and it forms the right angle there at B. Now, the first thing that you need to be able to do is to be able to identify the sides of this triangle. Now, the side that is opposite your 90-degree angle, it is called the hypotenuse, as you can see there. And the side that is opposite the given angle, in this case, our given angle is angle theta. So the side that is opposite, which is AB, it is the side that we name opposite. It is the opposite side. And the side that is next to the given angle, it is called the adjacent side. And this is the side which touches the angle, as you can see there. But the other side, which is the side AB, it is not touching your angle. Now that you are able to identify the sides of the right angle triangle, you should know something that is called a ratio. A ratio of the sides. In this case, we've got side opposite, adjacent, and hypotenuse. Now, if I can say, let's write the ratios of these sides. We're going to say one side which is opposite. I'm just going to write OPP for opposite, taking the first three letters and the first three letters there and the first three letters here. So we're going to write the ratios of the sides. So the ratio of the triangle using the sides. So that is the opposite over the adjacent. This is the ratio, and as I said, I'm only taking the first three letters. This is the ratio. If I can go on and write another ratio, I can write the ratio opposite divided by hypotenuse, and that is a ratio. So that's how you write the ratio using your right angle triangle. Now, the ratios of the sides of the right angle triangle, they are called trigonometric ratios. We call them trigonometric ratios. So in grade 10, there are three main ratios that you study, but they go hand in hand with their reciprocals. But the first three main ratios that you study is the sine ratio, the cos ratio, and the tan ratio. Now the ratios, they don't always go as they are written here, alone as sine, cos, and tan. They are always being attached to a specific angle. In our given triangle here, the angle that is given inside the triangle beside the 90-degree angle, because that is always going to be there because that is your right angle triangle, it is the angle theta at the vertex C there. So with respect to this angle, we're going to write our trigonometric ratios like sine theta, the cos of theta, and the tan of theta. Now, to be able to remember or to know exactly how are we going to write our trigonometric ratios, because I said that the sides of this triangle as they're making up the ratio, those ratios are called trigonometric ratios. But there's a way for us to be able to remember the trigonometric ratios. We're using an acronym called the SOHCAHTOA. So that is the acronym that is helping us to be able to remember our trigonometric ratios. The S, the C, and the tan here, and the T there. The S is for the sine, the C is for the cos, and the T is for the tan. So we have taken the first letters of our trigonometric ratios, then together with the sides of our right angle triangle. So the O here is for opposite, the H is the hypotenuse, the A is the adjacent. So for us to be able to define the sine ratio, we use the opposite and the hypotenuse. So our sine ratio, I'm going to take only the first three letters of the word opposite and the first three letters of the word hypotenuse. So the sine of theta, which is this angle here, it is the opposite over the hypotenuse. Still look using SOHCAHTOA, the cos of theta, it is the adjacent. I'm still going to take the first three letters of the word adjacent over H, and we said H is the hypotenuse. Then tan, it is going to be your opposite over the adjacent. So that is how you're going to define the sine ratios using the sides of your right angle triangle. Now, these three ratios, sine, cos, and tan, these are your three main your trigonometric ratios. These are the three main trigonometric ratios. But now they go hand in hand with their reciprocal. If I can ask you, if I've got a number 5 and I'm asking you to write the reciprocal of the number 5. So the reciprocal to be written, you take 1, you divide by the given number, which is 5. So it means in this case, 1 over 5 is the reciprocal of 5. Now, this is a whole number. What if you are given a fraction, which in this case you can say 3 divided by 5, and you need to write this as its reciprocal? There is a procedure that you just do, you just use algebra. As we said, you always take 1, you divide the given number, which is 3 over 5, because we're looking for the reciprocal of 3 over 5. Then I'm going to use this division line here. I'm going to rewrite that as a division sign. I'm still dividing 3 over 5. Now you know that when you divide a fraction, the best thing to do that is to change the division sign to multiplication sign and flip your fraction. Now you've got 1 multiplied by 5 over 3, and which is 5 over 3, because 1 is your identity element. Now we can see that, or the aim of us doing this whole calculation is for us to get the reciprocal of 3 over 5, which is now 5 over 3. So it means then that for you to get the reciprocal of a fraction, you just flip your fraction over. Because we initially had what? 3 over 5, and our reciprocal here is what? 5 over 3. I hope you see that. So that is how we write our reciprocals. Now, our trigonometric ratios, they do have reciprocal. So if I've got sine and I want to write sine as its reciprocal, then it's going to be what? It's going to be 1 over sine, because you always divide whatever that you want to make the reciprocal by 1. Then the reciprocal of cos, obviously that is going to be what? 1 over cos and the angle theta. And obviously that is going to be 1 over tan. But it's tedious to always writing your ratios as 1 over cos, 1 over sine, and 1 over tan. So we give them names. 1 over cos, we say that 1 over sine, we call that the cosec of theta. And 1 over cos, we name that the sec of theta. And 1 over tan is the cot of theta. Now, since we saw that the reciprocal of 5 is 1 over 5, and the reciprocal of 3 over 5 is 5 over 3, Now we have said that sine is the opposite over the hypotenuse. So if I'm looking for the reciprocal of opposite over the hypotenuse, obviously that is going to be what? Your hypotenuse over the opposite. So which means your cosec of theta is the hypotenuse over the opposite. Then your sec of theta is going to be the hypotenuse over the adjacent. That is just how you get your reciprocals, and that's how easy it is to get your reciprocals. I hope you do understand that. So that's basically how we define the trigonometric ratios together with their reciprocals. Now moving on to the next slide. When we compare the previous slide and this slide, we notice that our theta in this case, it is no longer at the vertex C, but it is at A. But nonetheless, we still have to use this to define our trigonometric ratios using the very same angle theta, but in this case, our angle theta, it is on a different position. So what happens when theta changes position? The adjacent and the opposite swap sides or position. Now, as you can see here, our theta, it is adjacent to this side. Hence, this side AB, it is now named the adjacent side. And our theta, it is opposite to that side. Hence, this side BC, it is named opposite. So you can see now that adjacent and opposite have swapped sides because theta has moved from vertex C to vertex A. So this is very, very important to see that the adjacent will not remain the adjacent as theta is changing position, and also the opposite will not remain the opposite side as theta is changing positions. Now let us go on and define our three main trigonometric ratios using this triangle now. So our theta in this case, as it is there, our opposite side, we're going to use the vertices of the opposite side, of the sides to define our trig ratios. So the opposite side is side BC. So we're going to say that because sine is the opposite, let me first write this, that is the opposite over the hypotenuse. That is our sine ratio. So the opposite side is side BC, and our hypotenuse is side AC. So that's how we define that using the sides of this triangle. And we said cos is the adjacent side over the hypotenuse. So our adjacent side is side AB, and our hypotenuse is still AC. Then tan of theta, we said tan is the opposite over the adjacent, and the opposite side, let's first write the opposite over the adjacent, and the opposite side is side BC over the adjacent AB. Now if I can ask you to go and write the reciprocals of these ratios. We said that sine is, the reciprocal of sine is cosec, which is 1 over sine, but we write that as cosec of theta. So it means then that because cosec is the reciprocal of sine and sine is b over c, using only the sides b over c, bc over ac, it means your cosec is going to be what? It's going to be ac over bc, because now that is the reciprocal. Then the reciprocal of cos is sec theta. So your sec theta, it is going to be AC over AB, because now that is your reciprocal. Then the reciprocal of tan is cot of theta, and tan is BC over AB. So what is the reciprocal of BC over AB? That is going to be AB over BC. And that is how you define these trigonometric ratios. Let's move on to the next slide. On the next slide now, we've got the triangle ABC, which is still your right angle triangle at B. And our angle theta, it is at the vertex A. I still want us to continue rewriting our sine theta cos theta tan theta together with their reciprocals. So the reciprocal of sine is cosec. You should not forget that. And the reciprocal of cos is sec. Theta, because the angle that is given is theta there. And the reciprocal of tan is cot theta. Now here I want us to use the small letters. How do we do that? Side AC, side AB is going to be called C, small letter C. Side BC is small letter A. And side AC is small letter B. So we're going to use those small letters to write our ratios and defining these trigonometric ratios. So we said that sine is the opposite over the hypotenuse. So our opposite side is side BC. But now our side BC is called A. So that is going to be A. And the hypotenuse side is side AC, which is now called B. Then that is how we define the sine ratio using those small letters. A here represent BC and B here represent AC. So we still using the sides of the triangle. Then our cos is the adjacent over the hypotenuse. So the side that is adjacent, your theta is C. So that is going to be C, and over the hypotenuse, which is still B. And tan is the opposite over the adjacent, and the opposite side is side A over the adjacent, which is C. Now, if you have written the main trigonometric ratios, it's always easy for you to write the ratios of the reciprocals. Because the ratios of the reciprocals, you just invert or flip the fraction over. So the cosec definition here is going to be your B over A, and the sec is going to be B over C, obviously. Then your cot is going to be C over A. So you can see that you just flip your ratio for sine, cos, and tan to get the ratios of cosec, sec, and cot. And that's how you easily do that. So moving to the next one. Now in this triangle, you can see that we do not have instructions that is telling us what to do. But now, as you saw on the previous triangles, we always have three sides. We always had three sides. So in this case, we've got two sides, PQ and QR, with the given values. The value or the length of PQ is 3, if that is the length. It could be that it is just the ratio, but the length there is 3. Let's say it's 3 units, and the length of QR is 4 units. Now, for us to be able to define all the 3 ratios, we need the measures or the length of all the sides. But in this case, we've got only the 2 sides, but we do not have the side of the longest side of a triangle, that is your hypotenuse. Now, there is this friend of ours. He's called Pythagoras. Pythagoras helps us to determine or to calculate the length of the side of a right angle triangle if the other 2 sides are given. I believe that you are familiar with the equation of Pythagoras, which says that your x squared plus your y squared equals r squared. Sometimes you start with r squared equals x squared plus y squared. It doesn't matter. That is an equation. That is an equation. Now, for us to be able to use this, remember, we use x, y, and r and these are taken from the Cartesian plane. But now we are using here, we're having here a right angle triangle, but we can relate this side x, y, and r with the sides of the triangle. So we can call this side our r, and we can call this side our x, and that side is going to be y. Now formulating this our own Pythagoras theorem, starting with the side r. Side r, it's side PR, but r here with a capital letter. So that is going to be your side PR squared, because that is r squared, equals your side QR squared plus your side PQ squared. Now we are looking for PR, which is r there. We substitute what we have. QR is 4 squared, so that is 4 all raised to the power 2 plus PQ, which is 3. Remember, that is PQ squared, so that is all raised to the power 2. Therefore, your 4 squared is 16 plus the 3 squared, which is 9, and the sum of this is 25. Then remember, we're still having what? Your PR squared, because we're having PR squared there. So we take the square root on both sides, then we're going to have your PR. We know that whenever you take the square root, the square and the square root are going to cancel, and on the right hand side you're going to have plus minus. But remember, we are calculating the hypotenuse side, which is always positive, so we can just say that is 5 units. So our R here is 5. Then once we have done that, we can go on now and define our trig ratios. But now, there's something in this question. We are given two angles, the angle theta and the angle alpha. So this is what I'm going to do. I'm going to write this with their respective angles, starting with alpha in this case. So that is sine alpha. We're going to define that using alpha, and also here we first use alpha, then we'll use theta later. Now with respect to this alpha, this side is going to be the opposite side. With respect to alpha, the side QR, which is 4 units, is going to be the opposite side, and the side PQ, remember, it is next to or adjacent to your angle, so that is going to be the adjacent. And the PQ PR side is always there, hypotenuse, that one doesn't change, it is fixed. Now let's define our ratios using angle alpha. So sine, we said it is the opposite over there. Let's write them. That is going to be the opposite over the hypotenuse, and cos is the adjacent over the hypotenuse. Then your tan is the opposite over adjacent. Now we're going to define this again using the given length or the numbers or the units. That is 3 units, 4 units, and 5 units there. So the opposite is 4 units. The opposite to alpha, that is 4 units over the adjacent side, which is 3. So the ratio using these numbers is 4 over 3. Then cos is the adjacent over the hypotenuse, and our adjacent side is 3 over, I have made a mistake. I wrote 3 there instead of 5 because the hypotenuse side is 5. So here our cos is adjacent, which is 3, over the hypotenuse, which is also 5. Then the opposite side over the adjacent, which define the tan ratio with respect to alpha, that is going to be the opposite, which is 4 divided by 3. So it is apparent now that if I can ask you to write the reciprocals, you're just going to flip the fractions over just like that, and you're going to write the reciprocals, which I'm not going to do because now I want to focus on the next angle, angle theta. Still using this the main three trigonometric ratios. So I'm going to use sine theta, the cos of angle theta, and tan of angle theta. So I'm not going to define them in terms of opposite, adjacent, and hypotenuse. I'm just going to use the sides, which is 3, 4, and 5. So according to this angle theta, the side that is opposite, it's that one, which is 3. And you can see that this angle theta, it is adjacent to side 4. And I said that your r, which is the hypotenuse, is always fixed. So defining here sine theta, it is going to be the opposite, which is 3, over the hypotenuse, which is still 5. And cos theta, it is the adjacent. Our adjacent with respect to theta now it's 4 over the hypotenuse, which is still 5. And tan, which is the opposite over the adjacent, that is going to be 3 over 4. And that's how you do this. That's how you define trigonometric ratios depending on where your angle of reference is. So you can see that with respect to alpha, our opposite side is QR and our adjacent side is PQ. But with respect to theta, our opposite side is PQ and our adjacent side is QR. And that's how you do that. And don't forget that if you are given two sides, you can always calculate the third side by using the Pythagoras theorem. Now, moving to the next one. Now, in this next example, we are given triangle EFG, and we are given sides EF and side EG. We need to calculate the length of the side FG. So let's first go on and rewrite our Pythagoras theorem as we know it. So we start with the hypotenuse. So we start with the hypotenuse, which is EF in this case. So that is EF squared equals your FG squared plus EG squared. Some people they decide to make whatever that we are calculating the subject of the formula here, so we can go on and do that. We are looking for side FG, so we are going to start with FG here equals to, so whenever you're calculating one of the sides which is not the hypotenuse, let me put it that way, which is not the hypotenuse, you always write that side first and you write the hypotenuse, which is EF, then don't forget that is squared, you subtract the other side, the other given side. It is just making one of the sides the subject of the formula, but it's always like that. So that is subtract side EG in this case. So it is just the same as subtracting EG squared on both sides so that we can make FG the subject of the formula. So let's go on and substitute what we have. Our side EF here is 17 squared. Subtract our side 15 squared. I need to go and take my calculator. Yes, so I'm just going to do it again. That is 17 squared. I'm putting the square root this side this time. The square root of 17 squared minus 15 squared, and this gives us 8. So our answer here for FG, it is equals to 8 units. So that is our 8 there. Then we can go on and use all the sides here to do what? To define the sides of our triangles using what? The trig ratios. Basically, we are defining these trig ratios using the sides of the triangle. So that is the sine, the cos, and your tan. So I use theta, but we do not have theta. I'm so used to this theta that I even write it even though it's not there. So we've got two angles that are given, that is alpha, and the blue one is beta. It may not be visible, but the blue one is beta, and I'm going to start with beta there. Remember, these are the Greek alphabets that are being used here to represent the angles in our trigonometry section. Now, according to beta, the opposite side is 15 and the adjacent side is 17. I hope you get the gist of this. Beta is opposite 15, and you know that your G here, it's the 90-degree angle. So the side that is opposite 90 degree, that is going to be your hypotenuse. Now, we define sine as the opposite over the hypotenuse. So that is going to be your 15 over the hypotenuse, 17. And your beta is next to side FG, which is we just calculated, there is 8. So that is going to be 8 over the hypotenuse, which is 17. And your tan is going to be the opposite over the adjacent, and the opposite with respect to beta, that is 15 over the adjacent, which is 8. That is the 15 over 8. Let me write it so that it can be clearly visible. So that is 15 over 8. Now I want us to go on and also define the reciprocals. Reciprocals, the cosec of beta, the sec of beta, and tan beta. So let's quickly do that. Cosec is going to be the reciprocal of sine, which is going to be what? 17 over 15. And sec is the reciprocal of cos, which is going to be 17 over 8. And I wrote tan twice, and I was supposed to write here cot. And cot is the reciprocal of tan, that is 8 over 15. And that's how you basically do that. So I hope you do get the gist of what is happening here. It's just a matter of being able to calculate the third side if it's not given. And for you to be able to do that, you use the Pythagoras theorem, and you go on and define the sides of the triangles that are required. Now, we are going to go on and use our other angle, that is going to be angle alpha. So we're going to start with our sine of theta, alpha, sorry. I'm so used to this theta. Sine of alpha, cos of alpha. Look at how I'm so used to theta. I'm always writing it everywhere, even though I have to write alpha. Now, sine of alpha. So according to alpha, the opposite side now is 8, and 15 is the adjacent side. So sine is the opposite over the hypotenuse, so that is going to be 8 over the hypotenuse, which is 17. Cos, our adjacent side in this case, is 15 over 17. And tan is the opposite over the adjacent, and our opposite side now is 8 over 15. And that's how you do that. You can go on and write the reciprocals, which you're just going to flip over your ratios and get the ratios of the reciprocals. Then we move on to the Cartesian plane. In your Cartesian plane, in the first quadrant, remember your Cartesian plane is divided into 4 quadrants. So the Cartesian plane in the first quadrant, we have got a diagram drawn, which is forming a triangle. So I want us to use this diagram to define the 6 trigonometric ratios. I'm saying 6 because I'm including also the reciprocals. Now, for us to be able to do that, let me write them. We're going to go to our diagram. Our angle J is alpha. But what we are doing here, it is exactly what we have been doing with just a triangle. But let me write all the trig ratios. Now in our triangle here, we've got our alpha angle here, and it is opposite y, our side y, and it is adjacent to side x, and our r is the hypotenuse. So y is the opposite, so it means our sine of alpha, it is y, which is the opposite, over r, which is the hypotenuse. Then cos is the adjacent side, and our adjacent side is x over the hypotenuse r, and tan, it is the opposite over the adjacent, which is y over the adjacent x. So to quickly finish up this, we are just going to write the reciprocals. That is, your cosec is going to be your r over y, your sec is going to be r over x, and your tan is going to be, your chord is going to be x over y. And that's how you definitely do it. I hope you do understand how we do this. This is just an introductory video to your trigonometry, and more videos are going to follow, where we're still going to do the calculations of the equations and using different diagrams. Thank you.